So we were interrupted about 2/3 of the way through the adolescence lecture before all this went down. So I was going to pull a couple of the key ideas that I don't think are quite as well developed in the textbook to sort of recreate a lecture here in a couple videos, and then have you guys do a discussion on one of them. For young adulthood, I will try to prepare videos for the complete lecture. So these videos for adolescents aren't going to cover everything because we covered quite a bit of it in class, and I think the text does a pretty good job covering a lot of it. But there are a couple things that I kind of want to revisit that we left hanging. And one of the things that we were sort of in the middle of discussing was this idea of secondary sexual characteristics. So if you'll remember that in puberty, there's two main traits that are developing and changing. One is the primary sexual characteristics. These are things that are directly related to reproduction, that they are somehow involved in either conception, fetal development, or pregnancy and birth itself. These tend to be very consistent, even across species. Mammals' primary sexual characteristics are pretty consistent. We can contrast this with secondary sexual characteristics, which are things that tend to have a lot of variety. And we also see that they are not directly related to reproduction, but rather to attraction. Right? Things like hair growth or changes in body mass or muscle mass or distribution of body fat. We also see a tremendous amount of variety in secondary sexual characteristics across the animal kingdom, with a strong gender dimorphism, with males tending to invest more heavily in these than females. Right, and we talked about how the secondary sexual characteristics are usually designed towards attraction, and many times we see that they tend to become dominant in the male because the male does the attracting. Right? If you'll remember, we talked about the Irish giant elk and the formation of the large antlers, which may very well have led to the extinction of the species, and how these males develop these antlers in response to female selection. Right, we contrasted natural selection, which is oriented towards survival, traits that help us survive, with sexual selection, which is all about attracting potential mates. We then had a conversation about what kinds of things people tend to find attractive, differences between men and women, with men often emphasizing, for example, youth over age. This likely reflects evolutionary pressures that female reproduction is in a much smaller window. We talked about things like the waist to hip ratio, which are physical characteristics that might predict a decrease in pregnancy complication. But the main thing, as we talked about, is this idea of receptivity, right? That the female is receptive to the male tends to be receptive to the female. And this all orients around this idea of female choice, that the minimum investment that a woman needs to put into a successful offspring in humans is probably 2 decades, right? But with men, it's much shorter, few minutes. It doesn't mean that that is what men should invest, but it is the minimum. This leads to a situation where the female is far choosier in terms of the mates and partners that they select, because they're the ones that are investing in the offspring, whereas the male, who is not the investor, has evolutionary pressures to be a lot less choosy, to try to attract as many potential mates as possible, as a way of maximizing reproductive success. We talked about some exceptions, like the seahorse, where the male is the primary caregiver, and in turn is actually the more selective of the genders. So secondary sexual characteristics tend to be all about attracting the female, right? So the male tends to develop these loud and intense signals as a way of attracting, and the female selects. The female doesn't have to develop these secondary sexual characteristics to the same degree, because they do the choosing, whereas the male is the one that has to be chosen. Where we left off was a discussion of this idea of testosterone, where the features of males that tend to have higher amounts of testosterone tend to be viewed as more attractive, generally speaking. Not the extremely high testosterone, but certainly the more testosterone compared to more estrogenized faces. They have linked it directly to reproductive success by looking at these ratios, where if you place your hand flat on a table, you'll see that usually for men, the second digit here, closest to the thumb, is going to be shorter than the fourth digit, closest to the pinky, whereas in women, the second digit is often longer or about the same size. This ratio is actually a good correlate for exposure to testosterone and has been shown to be a correlate for reproductive success in many environments as well. So all this is to say that testosterone does seem to increase the attractiveness of males. The problem is testosterone is a poison, right? It wrecks the immune system, it can wreck the organs, it can be very detrimental to the body. So why are women selecting a mate that is signaling high amounts of testosterone? One set of animals that can offer us a hint are birds. If we look at the peacock, we notice that the male produces these vibrant, bright, large, colorful tails that the females do find more attractive, and will select the males based on the gaudy tails. The female peahens don't create these tails. These tails actually serve as a big sign for predators to allow them to find them, makes it more difficult to escape, and they have to maintain a much larger territory in order to have food available to produce these tails. Generally speaking, it makes it much more difficult for the peacock to survive if it produces these tails. We see something very similar in the bowerbird, who will decorate their nest in red and orange colored beads and flowers and plastics and anything they can find. What we know is that some of the bowerbird's primary predators actually see best in the red and orange spectrum. So it's a giant neon sign that says, "Come eat me," to its primary predators. Sure enough, females will prefer to mate with the males that decorate their nests in these vibrant colors. All this seems to suggest that whether we're talking the Irishine elk, whether we're talking humans, whether we're talking birds, there's the selective pressure to produce traits that are detrimental to the health and well-being of the animal. And this comes back to the idea that if a female is going to select a high-quality mate, they need to select somebody who has good genes. Problem is you can't assess the genes by simply going up and asking someone. You can't just go up to a guy and go, "Hey, how are your genetics?" Right? They can lie. And they'll say, "Sure, they're great." They're not going to say, "Oh, no, they're terrible, full of mutations." Right? You need an honest signal, a signal that can't be faked. And what we're seeing over and over again in secondary sexual characteristics and sexual selection is that the females are choosing males that are developing traits that they cannot fake if they have poor genetics. A peacock with poor genetics who makes that big tail is going to be dinner. A bowerbird who decorates its nest but can't escape a predator is going to be dinner. All right? A human being that fills up their body with testosterone isn't going to be able to fight off disease, right? And the disease is probably one of the primary risks we face. It's one of the things that we're struggling with right now is disease and pandemic is most likely to be what wipes us out as a species, and testosterone actually wrecks our immune system. And it's kind of a way of saying, look, my immune system is so good that I can actually handicap it. I can actually diminish its effectiveness and still not show signs of infection. Right? And this is called the handicap principle. The handicap principle says that males will actually be selected to show traits that are honest, that can't be replicated, that are basically saying my genes are so good I can actually tie my hands behind my back and still perform better than this other male who wasn't able to make the same trait. Right? One of my favorite examples of this are the guppies. Young guppies will avoid predators at all costs, except if there's a female guppy around. Now, if there's a female guppy around, the guppies will actually swim right up to the predator before turning around and trying to swim away as quickly as possible. Sure enough, the females actually prefer those guppies that play this game. A poor quality genetic guppy who can't swim fast, can't escape a predator, if they want to play this game, they're dinner. Right? So it's an honest signal. Females who choose to mate with guppies that play this game and escape the predator are ensuring top genetic quality, whereas males who refuse to play this game might not have good genes and the females don't choose them to mate with. Right? So when we're thinking about secondary sexual characteristics that are developing right now during this time of puberty, what they often reflect are these selective pressures from our evolutionary past.